Before we start, we're going to have a poll, and I think our first poll today will be, have you any issues with water egress in your building? So if you pop through your yes, no, or maybe, and then we can start from there. Okay, so I'm going to hand over to my first guest, Lucy, and she is going to begin the session with what is tanking and why do we need it? Lucy.
Yeah, so hi everyone. I'm going to run you through the importance of tanking and how we choose a suitable product and key issues we can have on site even if we do select the right product. So the importance of tanking. So first of all, tanking is a method of preventing water ingress into a building by creating a completely impermeable waterproof barrier on a building exposed to moisture below the ground. There are a number of reasons why we should tank out below grade space. So firstly, and most obviously, it prevents water ingress into the basement space, which is primarily caused by groundwater. So if your building is located above the water table, there is still a risk of water ingress through irrigation or rain events as the water recedes to the natural groundwater level. So tanking also helps to prevent the ingress of rising damp, which is moisture from the ground rising up through the building through capillary action. Moisture ingress into a building can start to damage the interior space. It can lead to staining on your walls and delamination of your interior linings, causing damage such as paint bubbles or lifting of your flooring finishes. It can also impact the overall durability of your structure. An increase in the moisture within the building can increase the interior humidity and lead to dangerous mold growth, which can cause a number of health problems such as coughing to skin irritation, as well as damage to your mold sensitive materials. So there are a number of different types of tanking products, but they all aim to do the same thing, which is keep water out of your building to protect the interior space and protect the people inside from undue dampness and mold. So yeah, there are a number of tanking products from sheet membranes to liquid membranes to swelling membranes. So how do we choose which one is the most suitable for our project? To do that, we have to ask a series of questions. So where is the building located? Is it within the water table, and therefore will there be hydrostatic pressure acting on the building? Will the site water be contaminated? Will the soil be contaminated? Do we have access to the basement walls before or after concrete placement? Is the basement structure cast or precast? Will the membrane be pre-applied or post-applied to the structure? And is there any differential settlement below the structure? So once we've determined the criteria the tanking membrane needs to meet, we can select a membrane that meets those criteria as well as the owner's expectations of performance. So in the design phase, we can provide a project-specific design that is adequately depicted through design drawings and specifications. This includes showing the extent of the tanking and the typical details and the difficult transitions that may occur. The typical details are not always the default product manufacturer details as well. These are usually details that we know have proven to work well over time and go above and beyond the standard details. So during the construction phase, it is good to have a presence on site to monitor the progress and spot any issues that the contractor may be having with the membrane. So while on site, we like to observe how the membrane substrate has been prepared. Is it free from dirt and debris and holes and protrusions? How the membrane is installed prior to concrete placement. Is it flat against the shoring? Is there any damage from the steel reinforcement install? And how the membrane has been terminated, so at pile caps and at grade level. So while it can be a relatively straightforward task to design the tanking solution on paper, it doesn't always mean it will be installed perfectly on site. A few issues I have run into while on site include site water, as you can see on the slide. So one example of this is a project I was working on down in Wynyard Quarter. So the site was not dewatered and we were battling through very high water table, king tides and Auckland's rainy season, all with a moisture sensitive membrane. So not only was the site water on the membrane, it was also at times below it, causing big water bed type features around the site. So at the beginning, the site water was a big issue. We had to replace some of the materials as they became oversaturated. And eventually 2 water pumps were added to the lowest corners of the site to protect from the site water. So another issue that I've seen is membrane folding during the concrete placement. So due to the weight of the concrete being poured, the membrane can be pulled down and result in folded membrane. So a lot of tanking membranes require confining pressure to be effective. So these folds require remediation or complete removal. So for this, we have to develop a new detail for these folds. So, and finally, and probably the biggest one, is damage to the membrane. So as the membrane is placed over the whole slab where people are walking and working, the membrane is often damaged. It can be difficult to sometimes pick up on this damage if proper QA of the installed membrane is not provided. So I guess to summarize everything, providing a tanking membrane and selecting the right product is very important to protect your below grade interior space and the people that inhabit that space. But also following your design through construction will ensure the product performs as intended over its design life.
Thanks, Lucy. Just a quick question for you. The quality assurance programs in place, they become quite an important feature for this particular area.
Yes, definitely. So this is sometimes done by the installers of the membranes, but also some membranes have third-party inspectors come in to perform these QA.
Great, that's awesome. Look, we're going to roll now to our second poll, and so we'll intermediate between Lucy and Marius. So the second poll is, what type of tanking products do you normally specify? Those poll questions should have popped up for you, and hopefully you can fill it out and pop that back to us as soon as you can. A couple more secs there. Awesome. Okay, so thanks, Lucy. That's awesome. And now we're going to move on to Marius. And Marius, you have a view on a few issues. What can go wrong and what can make it go wrong? Over to you.
That's right, Mark. Just following on what Lucy had to say about site conditions and that. When working with Nuralite, we look at a sort of a 3-prong approach to selecting our tanking materials. Whether you're going to have a site that has no hydrostatic pressure, it's not sitting in a water table, water flows away from the site, it's a very, very low risk site. In a situation like that, you would use Bituthene 3000 on the walls, which is a self-adhesive membrane. This would protect the building from any rainwater getting into it, and they could just run with a plain DPC under the slab itself. The second approach would be looking at a more sort of a waterproofing level of protection. That's when you're building on a site where you do have groundwater running towards the building in heavy rain conditions and that. And for that, you would look at sort of a more secure torch applied system, the Nuralite 3PT and the 3PTM, which would go underneath the slab. Our third approach would be for a complete watertight basement. These are generally for high risk situations, basements that are exposed to continuous hydrostatic pressure. And for something like that, you would look at the PreProof Plus, which is our top of the line product and can withstand high hydrostatic pressure, fully bonds to the substrate, and gives you a complete watertight seal of your structure. As Lucy mentioned earlier, there are a number of different tanking products available on the market. Choosing them, you've got to take a lot of consideration into what the aspects and performance characteristics of these products are. We have a bit of a table which we'll look at, and you look at the different types of membranes you get. So obviously you get your bitumen torch applied, you get your bitumen which are just laid underneath a slab and they bond mechanically with the aggregates that are in them to the concrete that's poured. You get your self-adhesive membranes, such as the Bituthene 3000, which has an HDPE facer protection layer on it. You get your thermoplastic membranes. With those, you get 2 types again. So you obviously get the ones that have a chemical adhesion that bonds to the concrete. That is, for example, the Preproof 300. And then you also get your thermoplastic membranes, which bond to concrete via mechanical, as they have fibers on the one side. So it gives you a mechanical full bond to it. You then also have your sodium bentonite membranes, which will also have a mechanical bond with the fibers on it, and your PVC membranes, which are generally loose laid over your site, and they're welded onto PVC water bars around it. They're generally just loose, and they form compartments. They usually refer to them as compartmentalized system. As you can see in the attached table, we have a lot of different sort of performance characteristics of these membranes, and it shows clearly which membranes perform in the best in different situations. This is the reason why, according to this table, Nuralite has gone with PreProof and Bituthene as their premium product. As you can see, they outperform basically any other system that's out there. To give you an example of what the PreProof and Bituthene 3000 products are, this is the Bituthene 3000 system installed on a site in Auckland. It's a high-density polyethylene membrane facer. It's made up of an SBS, which is a rubberized bitumen membrane, and it is cold applied and self-adhesive. It's a preference to use on sites, especially when you're below grade and you've got tight compaction, as there's no need to use a torch or a flame. It's cold applied, it goes on quickly, and it gives you high confidence in the performance of the system.
Marius, on that, are there any temperature issues for these types of products?
Temperature issues for that is they can be installed at certain temperatures below grade, so you wouldn't generally, if it goes below 5 degrees Celsius, you wouldn't install it. It'd be a bit cold on site.
What would be the options?
For the options on that, if you get really low temperatures, we could possibly look at using the torch applied membranes then.
Right, okay,
yeah.
Great. Just while we're moving on through to the next slides,
yes.
If you do have any Q&A questions for our panelists, please pop them through. I see we're starting to get a number of the questions come through. Fill out in the Q&A section and we'll put those questions to our panelists at the end of the session. Marius.
Great. The next products we're looking at is the 3PT and the 3PTM. The 3PT gets used below this. 3PTM gets used below the slab. It has the mineral chips on it that form a mechanical bond to the slab as it's poured. And the 3PTM would be our post-applied membrane, which then gets torch applied to the slab, to the concrete walls, block walls, precast panels. It's a good product to use when you have the right site conditions for it. And then we're having a look at our PreProof Plus. This photo was graciously given to us by the installing contractor Sansom, who did this work on the Commercial Bay project. As you can see, PreProof Plus is used in this situation. It's a high hydrostatic pressure site. There's a lot of pile detailing. The PreProof system has excellent details to deal with piles. It has excellent details to deal with any penetrations in the system. It has a full system of components to go with it. And it is used in sites where you have a high risk of water getting in, also sites that are high risk of chemicals or sulfates or hydrocarbons. Getting a bit more into the PreProof membrane itself, this is just a bit of a diagram, and the following slides will just lead on from that, showing you exactly what the system components are. The PreProof itself is made up of a high-density polyethylene membrane, which then has a pressure-sensitive adhesive layer on top of that, which helps bond to the concrete. That is then protected by an acrylic layer over the top. This acrylic layer helps the membrane protection during work on site, so the contractors can go and lay the membrane out. It then protects the membrane from the steelies coming to put their rebar in, the reinforcing, following works prior to the concrete being poured. A brief diagram here showing exactly how the PreProof adhesion system works. So as the concrete is poured onto the site, it passes through the first protective layer, which then activates the adhesion layer underneath it. The heat generated by the concrete causes a reaction between the pressure. It's a pressure-sensitive adhesive, which is bonds to the concrete as it cures, and the concrete will then literally grab the PreProof membrane and pull it into itself. So it becomes an homogeneous full seal and an impenetrable barrier.
Is that controlled by the limes and the content of the concrete that creates that heat, Marius?
It's just a curing action in the concrete. As concrete cures, it naturally generates a heat in it. And this sort of generation of the heat assists with the bonding of it. That is why it's critical to leave it on for a full, to leave any sort of reinforcing, not reinforcing, but protection layers on for the full concrete cure period. This is another sort of demonstration just to show you here from a site level sort of level. Here you have your reinforcement placed in. The concrete is being poured onto the pre-proof membrane. And having a look at it from a microscopic level, you can see on that diagram over there how the pre-proof itself actually bonds to the concrete and forms a complete homogeneous seal. This seal will prevent any water tracking between the membrane and the concrete, should there by any chance be a penetration in the membrane that was not picked up prior to the concrete pour. Now, looking at the risks of not having a fully bonded system. Now, obviously, you get two types of bonds. You get a full mechanical bond and you get a full homogeneous seal bond. Mechanical bond, unfortunately, still allows for traction, water to track between the membrane and the substrate. If you look at the diagram on the left, the A-B section shows water. Obviously, there's a penetration in the membrane and water's tracking between the membrane and the concrete, looking for basically a weakness in the concrete where it will get into the substrate. On the opposite side by C, that is a full chemical homogeneous adhesion. That doesn't allow any water to travel between the membrane and the concrete, so you won't get any water tracking into the system, into your substructure. On the right, just another diagram illustrating to us exactly what happens when you don't have a full seal. As water could come in from anywhere. You could have rainwater, groundwater coming in from the top, groundwater coming in from below. There's no sort of full seal and adhesion between the membrane and the concrete, and you'll have tracking between the membrane and the concrete. With this type of breach, they can go in and they can do a crack injection. It will repair that section, but unfortunately, the water will look for the path of least resistance, and it will move along to the next crack in the concrete, and you'll just have to continuously crack inject and do repairs. Giving you an example of how sort of you have failures in the systems and that, I've looked for examples. These are two sites that are based over in North America. They're both sodium bentonite projects where there have been failures in them. Firstly, this first site over here, what happened was they had rainwater coming down from the roof. You can see the primary roof drain at the bottom over there. What happened was the roof drain was actually pumping water out every time they had a major storm. This resulted in the sodium bentonite granules, which is in the geotextile fabric, to be completely washed away. And with that happening, it allowed water ingress into the basement. Going through to the next site over there. This is another site. This site was deemed as the most expensive basement repair in North America, or in California. This was a car park basement that had a $3 million crack injection repair. As you can see, the site was built using shotcrete, a bentonite panel, and obviously compaction, which is the main sort of requirement for a bentonite system, is you require compaction to ensure that it works well. In this site, it didn't have the required compaction, and the bentonite obviously was pushed away from the substrate, resulting in constant leaks. You can see on, yeah.
Sorry, Marius, just a quick question. Is compaction a big issue in New Zealand?
Compaction is a big issue in New Zealand. Unfortunately, in New Zealand, we do a lot of brownfield building. And when you're building on a site and you're reusing that site, you can go in, have your basement constructed. The following contractors can do quite a good job at compacting, but then you don't know what's going to happen if you have liquefaction of the ground, if there are any tremors, if there is work going on in a site 2-3 years down the line, right next to the building that you've done. All of these can result in compaction of the bentonite systems falling away, and will then result in a failure of the system.
Thanks.
Again, on this picture, you can see there is, you can actually see the amount of the foam grout, the crack injection resin that was used to carry out the repairs on the site. Yeah, and that's about it.
That's your bit. Thanks, Marius. That's a great overview of some of the key areas when you're considering your waterproofing options. I have a question for Lucy. Lucy, the challenges around tanking can be and unintended consequences. They can be things like penetrations coming through pipes and rebar and all these things. Tell us a wee bit about some of the thinking behind, how you deal with those things.
So you try and tend to deal with penetrations at the design stage, but we would have a typical penetration detail that details the penetrations with accessory products to kind of add that penetration to the tanking line.
Yep. Okay, great. The some of the challenges around building sites can be things like tree stumps and roots that will grow through. What is the thinking behind that?
That's not something I have come across yet, as you would have to remove the trees or plan for them before you got into construction.
Yep. Okay, so making sure that we have a clear pathway, but also, over time things, do grow. And Marius, we've got a product that may be suitable in that space.
Yeah, we generally use Nuraply 3PG membrane in that space. The 3PG would have a root inhibitor in it, which would prevent the roots from penetrating the membrane.
Yep.
The main problem you have with membranes, with the roots penetrating, is not so much the membrane itself, but it's more to do with the laps. And the membranes will generally find their way through the laps. So it's also a point of reinforcing those laps on site.
Okay, good point. Now, in the Q&A process that we've asked for, we've actually excelled ourselves. So we may not get through everybody's questions, but we'll have a really good go at it. So we have a question here. Do we have a third scenario for our precast walls? Or what would be the recommendation for precast?
Our recommendation for precast, depending on the site, you could either use the Nuralite 3PT tanking membrane to torch apply to that, or you would use the Bituthene 3000 self-adhesive membrane on precast panels. On most sites where we work, where they use the PreProof system, they would use the PreProof under the slab, and then that would tie into the Bituthene 3000 coming down the precast panels. It's designed to work as a system together. They come from the same manufacturer. And the same would apply for our 3PTM and our 3PT membranes.
Okay, great. Lee, you've got a question. Does Bituthene adhere to wet walls?
Bituthene won't adhere to a wet wall. It will adhere if you have a wall that is slightly damp and you use the Bituthene B2 primer, which would seal the dampness in it. You can then use the Bituthene 3000 on that wall, on green concrete. But again, we wouldn't recommend that on anything less than 7 days.
Okay, that's great. Question for Lucy. Quite often polythene or DPC is installed in building sites around the country. Where would the changeover be where you wouldn't use a DPC? In subterranean areas, is that a suitable option for you to consider?
It's all dependent on the water table. So if your building is within the water table, it's a good idea to tank it. And if it's above the water table, a DPC is suitable, but to future-proof it, tanking is probably a good option.
DPC is not considered waterproofing or in the building envelope, or is it's more of just to stop moisture coming through into the slab? Is it?
Yeah, it's more of a vapor control measure.
Vapor control as opposed to a waterproofing option.
Mm-hmm.
Yeah. Okay, that's awesome. Hero, can we use torch on to heat up the membranes in cold weather climates?
Bituthene 3000, no, we wouldn't recommend using torch on for that. Obviously, with the 3PT system, yes, you would use a torch for that.
Okay, so that also leads into that cold climate question in the South Island. Really, below 5 degrees, you'd be looking at an alternative product to the peel and sticks.
Not 5, -5, I'd say.
Down to -5 for peel and sticks?
Yeah.
Okay. And the
And also,
primers,
obviously not having any frost on the substrate.
sure, and the primers activate so that you can get a
The
good
primers
tap.
activate, yeah. I mean, you can always heat the substrate up with a torch. If you want to apply the Bituthene 3000 onto the substrate, heat it up with a torch, but don't actually use a torch on the membrane itself.
Okay, that's great. We have an interesting question here that may or may not be able to be answered in this session. A question's come through about polythene blocks, polystyrene blocks, and we're seeing a lot of these now, particularly in residential construction, where they're filled with concrete, and of course some of them are used below ground. And what would the tanking option be for a polystyrene block?
We would use Bituthene 3000 for the polystyrene block. You would have a water-based primer on that. So, for example, the Nuraflux number 10 primer, and that would be a water-based primer to give you a good adhesion, and then you would just apply the Bituthene 3000 to that.
Lovely. Look, we're just about at our half-hour session time now, so I'm just going to wrap this up. Just two quick polls to put out there. The first one is, would you like to rate our presentation today? We'd love to get your feedback. These webinar sessions are designed primarily to open up information channels and allow people to contribute positively to these sessions. You may be aware Nuralite does have a number of webinar sessions. We're continuing with these over the next few months. In fact, now because of lockdown, we may actually bring some of these forward to keep the interest in some of the sessions that we have. The second poll would you like to have a follow-up with some of the information that we have? Now, because you've participated in this session, all the information that we have today, that includes our PowerPoints, the questions, the presenters' information, will go out to you via electronic means. And if you have any further questions from that, please come back to us, and we'd love to pass on those questions and assist you with any projects that you have. So on behalf of Nuralite, I'd like to thank first our presenters, Lucy and Marius. I think that it's been very informative for the information that you've presented today. It's a really interesting space for subterranean tanking, and I'm sure there'll be a lot more questions that come from that. So on behalf of Nuralite, thank you to everybody that's participated, and we'll see you in our next session coming up. Please check our website out for future information.